We are asked, using 5 subintervals and left endpoints, approximate the integral from -2 to 3 of x cubed plus 1 dx. We're also asked, will this be an underestimate or an overestimate? So before we begin, let's just review the definition of our Riemann sum. Notice here that it's asking us to take 5 subintervals and to use left endpoints. So we're going to be using a left Riemann sum. The definition of our left Riemann sum is a little different than our right or our midpoint. The left Riemann sum just says that if we have the integral from a to b of f of x, some function f of x dx, this is going to equal the limit as n approaches infinity of the summation from I equals 1 to n of x sub I multiplied by our change in x, or delta x. We've also defined x sub I as our starting point, our leftmost point, plus I minus 1 times our change in x, delta x. We also know that delta x is going to equal b minus a divided by n. And obviously, as n approaches infinity, and if we use this method, this would just get smaller and smaller and smaller until we would have infinitesimals there. We are not going to use the limit as n approaches infinity. We are just asked to approximate it using 5 subintervals, not infinite subintervals. So that's the only difference in what we're about to do with this approximation and this formula here. We can use every other part of it except for the limit. So, first off, let's say we know that a is going to equal -2. b is going to equal 3. So a is equal to -2. b is equal to 3. And x sub I, our formula for x sub I, is a, so that's going to be -2. So x sub I is equal to -2 plus I minus 1 times our change in x. Now what's our change in x going to be? Well, we have 5 subintervals, that's going to be our n. And b minus a, well, this is just going to be 3 minus -2, or 3 plus 2. And that's all going to be over 5. So 3 plus 2 is 5. And when we put that over 5, we just have 1. So our that's a lucky thing to have. It makes it very easy. We're just multiplying this whole thing by 1. And when we write our sigma notation here for our summation, we just get the sum from I equals 1 to 5. F of x is just going to be something cubed plus 1. And that something is just going to be this right here. So I'm just going to plug this in. -2 plus I minus 1. That's going to be cubed plus 1. Let's see if we can simplify this just a little bit further. Alright. This is going to equal the summation from I is equal to 1 to 5 of I minus 3 cubed. See, our I is positive, we have a minus 1 here, a minus 2, so we just combine those, we get minus 3. All of that cubed plus 1, and the plus 1 is also going to be part of our summation. So before we tackle that, let's just take a look at what our function here looks like over this interval, because that's going to give us some intuition as to whether or not this is a overestimate or an underestimate. And a good place to start is when x is equal to 0. So when x is equal to 0, we just have x cubed is 0 plus 1. That's going to get us to 1. Notice I already have our tick marks here, and I've condensed them in the y direction here. They're a little more spaced out in the x direction. I've already drawn some boundaries here where our interval is going to be. So we have -2 is going to be right here. +3 is going to be over here. And we know that the left and rightmost endpoints are going to be on these lines here. When x is equal to 1, well, 1 cubed is just 1, plus 1 brings us to 2. When x is equal to 2, 2 cubed gets us to 8, plus 1 more is going to get us to 9. So 5, 10 minus 1, 9, yep, there we are. And when x is equal to 3, that puts x cubed at 27 plus 1 is 28. So that's going to be all the way up here at 28. Let's see, 5, 10, 15, 20, 25, 26, 27, 28. It's going to be right there. Now, when x is equal to -1, well, that's just going to be -1 cubed is just -1. Plus 1 is just going to be 0. So here when we have x is equal to -1, our y value is just going to be 0. And finally, when x is equal to -2, that's going to equal, x cubed is going to equal -8, plus 1 is going to be -7. So 5, 6, 7 in the negative y direction, and we go over and we put a dot right here on our boundary. So our function, let's see, let's pick a different Crayola color here. Maybe we'll choose, oh, I don't know, maybe we'll go with green or something. Our function is just going to look like a third-degree polynomial here, and it's just going to be raised by 1 at the origin here. So this would continue, obviously, and this is going to curve upward and hit that point. It's going to go up to there, and then finally all the way up to there and beyond. So this is going to be our function here. And we are asked to approximate this using left endpoints. So if you just imagine if we're using leftmost points to approximate our area, well, if this is a leftmost point down here, then we have we have an entire rectangle here in the negative direction. And if this is a leftmost endpoint here of this subinterval, well, then we have a rectangle that has a height of 0, so that's just going to be empty right there. If this is a leftmost point along the interval from 0 to 1, 0 right there, then we're just going to have a rectangle of height 1 right there. Notice that we're scaled, so it appears a little bit squished. And if this is a leftmost endpoint along the next interval, we're just going to have a rectangle of height 2 there. And see if I can draw this as neatly as I can. And there we are. So we'll shade it in. We'll go back to this after we do our calculation just to see if this makes sense. And there we are. So this is the area that we should be calculating. Now, let's go back to what we did before. Notice that we figured out that we need to solve for this summation right here from I equals 1 to 5 of I minus 3 cubed plus 1. Alright, so the first thing we need to do is we can just expand our cubed expression there. And let's see, what's this going to equal? Well, we could just use Pascal's triangle. I equals 1. Or we could just use any of our polynomial cubed formulas. This is going to be I cubed minus 9I squared plus 27I. And then we have minus negative 3 cubed is just minus 27. And then we have a plus 1 here at the end. So obviously we only have one I cubed term, only one I squared term, only one single I term. But we can combine negative 27 plus 1. That's just going to give us minus 26. So just remember that for the next step. And then we can just distribute our sigma form here. And that's going to give us a summation from I equals 1 to 5 of I cubed minus, we're going to pull this 9 here out of the next summation. We can do that if you just remember our summation properties. Of I squared, we're going to pull the 27 out for the next one. I equals 1 to 5 I. And now we have minus, remember we said that minus 27 plus 1 equals 26. Summation from 1 to 5 of, we just have a 1 here. So hopefully that makes sense. And for this next step, you might want to go back and just review your summation formulas. We're going to move a little bit quickly here because that's not the focus of this video. So let's see. I know that the summation from 1 to n of I cubed is just going to be n times n plus 1 over 2, all of that squared. Our n is 5 in this case. So that's going to be 5 times 5 plus 1. Oops, sorry, our square is going to be out here. All of that over 2. Minus 9. And here we have the summation from 1 to 5 of I squared. And this is going to equal, put it in brackets here again, 5 times 5 plus 1 times 2 times 5, which is 10, plus 1 over 6. And we'll write the next one out, plus 27. The summation from 1 to 5, or 1 to n of I, which is just n times n plus 1 over 2, or in this case 5, times 5 plus 1 over 2. And then we have a minus 26. And anytime we have a 1 here in our summation, that's just going to be multiplied by n. And in this case our n is 5, so that's 26 times 5. Alright, for this next step we're really going to test your arithmetic skills here. We have 5 times 6, which is 30, divided by 2, which is 15. 15 squared is 225. Alright, and here we have a 6, here we have a 9. Let's simplify this a little bit. We don't have it, this is just a 1 up here. If we had a squared, we wouldn't be able to simplify it like that. But here we have a 6, so let's see. 3 goes into 6 2 times. That's just a 2 down here. 3 goes into 9 3 times, so we get rid of the 9 and we just have a 3 out here instead. Anytime I simplify, I like to cross things out and then put the what's left over in brackets. That's just my way of doing things. So don't forget we have a minus here. 5 times 6 is 30. Divided by 2 is 15. Times 11 times 3. Let's see. Let's figure that up again. 5 times 30 times 11 is going to be 330. Divided by 2 is going to be 165. Times 3 is going to give us 495. Sometimes the order that you figure things up in makes it a little easier. This is a good workout for your brain. Over here we have 27 times 5 times 6 is 30, divided by 2 is 15. 27 times 15 is going to give us 405. And finally we have our 26 times 5, which is just going to give us 130. Alright. So right off the bat, I noticed that here we have a minus 495. Here we have a plus 405. So we could consolidate these two terms. I'm just going to draw a little tree here, and we'll try not to ignore anything, but just remember we have some branches that we will be getting back to. So if I just cancel out the 4 here, cancel out the 4, cancel out the 5 here, I'm just left with negative 90. And here I have a negative term, here I have a negative term. Minus 130 minus 90, that takes us to minus 220. And don't forget we still have a plus 225 out here. And when we subtract 220 from 225, we just get the answer is 5. Alright. That was a long way to get there. Let's go back and look at our graph here and see if this makes sense. So this should equal 5. Alright, so well, we know that this rectangle here is just equals 0. This one is going to be, remember the bases are just 1, so the area of the rectangle is just going to be whatever the height is. In this case it's -7. So that's -7 times 1, that's -7. Plus 0, plus 1 here, plus 2, plus 9, I believe. Yeah. Alright. And we could do this in the most straightforward fashion here. 9 minus 7 gets us to 2, plus 2 is 4, plus 1, sure enough, yep, it equals 5, which is the answer that we got when we did all of this business here. Now, keep in mind, this is not the same as the integral. This is not the same as the area under the curve here. In fact, if you look at the interval, from 0 to 3 especially, this represents the greatest interval of our function here, and this is going to be curving upward, so that means that we're going to have an underestimate under this curve. So if we have an underestimate under the greatest interval that we care about, then chances are this is going to be an underestimate. And in fact, when you look, I know this is just kind of a visual argument here, but when you look here from -1, from the interval from -1 to -2, this almost looks like you're just sort of cutting this rectangle in half. And clearly these rectangles represent or the area under this part of the curve represents a greater chunk of our area that we are trying to approximate here. So I would argue, based on that this is going to be an underestimate. So this is going to be an underestimate. So we know that now we have a lower bound for our integral here. We know that the integral from -2 to 3 of x cubed plus 1 dx is going to be greater than 5.